This is Mrs. O'Neill for AP Chemistry, Chapter 16, Section 11, Lewis acids and bases. You've already learned about the Arrhenius acid and base and the BrØnsted-Lowry acid and base, and those were two definitions that they gave you in the very beginning of the chapter. Lewis, however, they keep for the end because it's a little different. So you're going to learn that a Lewis acid is an electron pair acceptor and a Lewis base is an electron pair donor. So pause the video, fill in those two words, and then play to hear mine. So an acid, we always talk about an acid first. So a Lewis acid is going to be an electron pair acceptor, and a Lewis base is an electron pair donor. Now, the weird thing here about a Lewis acid base is that we usually refer to the base first. We usually kind of say, well, in this reaction, which one is the base? The electron pair donor. I always like to think of it that way because you're going to see that an acid is really hard to how do I want to say, identify in these types of reactions. So what do I mean by that? Let's look at ammonia again. How do we know that ammonia is a base? Well, if we look at it from the BrØnsted-Lowry, so we look at ammonia in water, that water is going to donate a hydrogen or donate that proton to the ammonia, making the ammonium polyatomic ion, and there are your hydroxide ions, and those hydroxide ions in solution are going to make it a basic solution. So we know that ammonia is a base. However, if we look at this reaction, we know that ammonia is widely used in fertilizers, plastics, and explosives. And in this case, this is a ammonia reacting with boron trifluoride to make this compound. Well, notice it is really difficult to figure out which one's the acid and which one's the base in this reaction. Well, I already know that ammonia is a base. So how did Mr. Lewis say, how is this acting as a base in this reaction when I don't see any hydroxide ions and I really don't see H plus ions floating around either to be able to give or protons to be able to give or donate? So he said, look at that electron pair. That electron pair is being given to the boron trifluoride to come up with this compound for this reaction, and that's going to be our base. So again, here's our example. We have boron trifluoride reacting with ammonia to make this big compound. So what's really happening? Well, we can look at it two ways. We can say that boron trifluoride wants more electrons, or we can say that ammonia has more electrons to give. And that's what I mean by always referring to the base more in this Lewis acid base component. Because when I look at these two things, it is very difficult for me to figure out which one is the acid, but I can look at the ammonia and know, oh yeah, I know ammonia is a base, and it's a base because it has these two electrons, the pair of electrons, that are going to be given away. So I always like to think of whatever component, whatever compound is going to have more electrons to give is going to be the base, the Lewis base. So those electrons are going to be converted over to that BF3. So which one is which? Since that one's going to be the donor of those electron pair, that's going to be the base. And here again, then that's got to be the acid, right? You have to have that acid-base pair. So that's where that compound, it's a really complex compound. You don't see it often, but you do see Lewis bases making these weird compounds because of donating that electron pair. So if we look at something like this, if we look at H plus and OH minus, again, which one has more electrons to give? So if I look at this, the OH has more electrons to give. That's another indication that that's a Lewis base, and then that other guy's got to be that Lewis acid forming that water. Again, kind of a weird way to look at things, but we want to remember which one has more electrons to give is going to be the base. So pause the video and give it some thought. Again, must have an unshared pair of electrons in order to be that base to give to that other element in a compound. So can you identify which one's going to be the base and which one's going to be the acid? Again, I always refer to the base first in Lewis because the base to me is the one that has more electrons to give. Hopefully you got that. And hopefully you got that. Again, that negative, that Cl negative, has more electrons to give, so that's going to become the base. So if you want to pause and kind of fill in your chart there, hopefully this makes sense and an easy way to remember. Again, I like to remember the ABC. I like to remember how we learned it. We learned about the Arrhenius first, and that's based off of the compounds H plus and OH minus. Then we learned about BrØnsted-Lowry, and we talked about H plus and how pH is always referred to because of how much H plus ions are in there. And then at the end here, we talked about that Lewis. And again, we're thinking about that electron pair. So can you answer these questions? And we'll see you in class and hopefully ready for that test.